Hey guys, today we are going to move into section 7.2 and look at the wonderful world of inverses. Now, in math before, you have heard the word inverse. An additive inverse is the fancy way of saying the opposite. So like positive 3 and negative 3. They're opposites, but they're also called additive inverses of one another. The multiplicative inverse is the fancy way of saying reciprocal. So 5 and 1 over 5, yes, we typically call them reciprocals, but their fancy name is called a multiplicative inverse. The cool thing is, just like you have additive inverses and multiplicative inverses, you can find the inverse of relations. Now remember, a relation is just a set of ordered pairs. So that set of ordered pairs may be represented using an XY table. Your set of ordered pairs can literally be a set of ordered pairs, a pairing of X and Y. Okay, now what happens is if you have an inverse relation, you switch your X and Y values. They switch. And graphically what happens is that you get a reflection across the line y equals x. So if you visualize where this line would be, it would have to go through all the points where the x and the y values are the same. So if x is 0, y is 0. If x is 1, y is 1. If x is negative 1, y is negative 1. So your line y equals x is a diagonal line that cuts through quadrant 1 and quadrant 3. Now what happens is if you take a relation, a set of ordered pairs, whether it be in a table or just a given set of ordered pairs, if you graph them, then you find its inverse, meaning you switch your x and your y values, and you also graph those, your images would be a reflection over that line. So let's go ahead and try a couple of those. Okay, so they gave us a relation, just a set of ordered pairs. So step 1, it says to graph the relation and connect the points. So we will do that. This is your x, this is your y. So don't go left or right, just go up 2, there's a point. Go right 1, up 5. Go right 5, up 6. Go right 8, up 9. Connect the points. Okay, so that is your relation. Now what happens is they say to identify the domain of each relation. Now remember, the domain is the x values and the range, they are the y values. They had us connect the points. So that means when I'm looking for the domain, the smallest x value is a 0. So x is in between 0 and the largest x value is an 8. So my domain tells me that our x values are in between 0 and 8. Now your range are the y values. So the lowest value on my y-axis is a 2. Range is y, so notice I did use the variable y in this case. The highest that I go on the y-axis is 9. So we graphed the relation, we connected the points, we identified the domain and range. Now it says create an inverse function table. So what that means is we are going to go ahead and take this table and now make an inverse table. So you switch your x and your y. So 0 over 2 now is 2 over 0. 1 over 5 is now 5 over 1. 5 over 6 is now 6 over 5. 8 over 9 is now 9 over 8. So this is called your inverse function table. We flipped all of our x's and our y's and we kept it in table form. So now we're going to graph these on the same grid. So if I go to the right 2, stay at 0. Go to the right 5, up 1. Go to the right 6, up 5. Go to the right 9, up 8. Connect. Now notice here is that line y equals x. This is a reflection. So when I did the inverses of my original relation, I did get a reflection over that line, y equals x. So that's just one way to check your work and make sure that you're on the right track. Now it says to identify the domain and range of each. So now let's go back and figure out, okay, what's the domain and range for our inverse function? Domain is left and right. The smallest value that it's touching on the x-axis is a 2. So x is in between 2, and the furthest that I go to the right is 9. Now y is up and down. The lowest point is at a y value that is a 0. the highest point is at a y value that is an 8. Now, one thing, I know some of you are recognizing this. I totally know you are. Notice our domain, x was in between 0 and 8. In the inverse function, that's what our range is. Our range is now in between 0 and 8. In our original relation, our range was all the values in between and including 2 and 9. But now that 2 and 9, that is the domain of our inverse function. And this makes sense because an inverse switches the x and the y. The domain represents the x's. The range represents y's. So when you switch them, it only makes sense that your domain and range would switch as well. One more, and that is just kind of the first little idea for the day. So again, we'll just make sure that we've got this. Step 1, graph the relation and connect the points. So I go to the right 1, stay at 0. Go to the right 3, up 1. Right 4, up 2. Right 5, up 3. Right 6, up 5, and connect. We got a little curve. Okay, so let's look at the domain and the range. The domain, the smallest x value is 1. Domain is the variable x. The furthest that I go to the right is 6. So your domain includes all of the x values from 1 all the way up and through 6. Now your range, the smallest y value is 0. The largest y value is 5. So your y values are anything in between and including 0 and 5. Now we have to create what's called an inverse function table, or an inverse table. You take every set of ordered pairs and you switch the x and the y. So 1 over 0 is now 0 over 1. 3 over 1 is now 1 over 3. 4 over 2 becomes 2 over 4. 5 over 3 becomes 3 over 5. And 6 over 5 becomes 5 over 6. This is an inverse table because it followed the definition of an inverse that says you just have to switch x and y. Now if I graph it, 0, 1, go to the right 1, up 3, go to the right 2, up 4, go to the right 3, up 5, go to the right 5, up 6. Connect them. Again, we see that yes, we do have a reflection over that line y equals x. So again, it's just another way to check. Now to find the domain and the range of our inverse. The domain, the x values go from 0 to 5. And if you look, that was our range for our original relation. So the range became the domain. Now the range, the y values go from 1 to 6. That was our original domain. So now the y values are in between 1 and 6. So that is our first idea. Being able to find the inverse of a relation, graphing it and visually seeing, okay, what is the relationship on a coordinate plane if you are graphing inverses, and then noticing that the domain and the range would switch. Turn page. Okay, now this is super cool. You can take a function. So remember, function, you have that equation and it has f of x. That's that function notation. Remember, f of x and y are interchangeable. So what that means is anytime you have f of x and you have y, you could interchange the two values without altering the meaning of the function or the equation itself. So I'm just going to jump in and show you these because I think it makes more sense to just do it, okay? So if I'm going to find an inverse function, the definition of an inverse says I have to switch x and y. Well, if you have something that's in function notation, currently it doesn't have a y. So your first step, you change f of x into y. That is step 1, and that would be worth a point. When you get to your quiz and test for this chapter, changing f of x to a y, that's a point. Now to find the inverse. The definition of the inverse says you switch x and y. So x and y change places. That's the inverse. Now your inverse function is what you get when you solve for y. So that means now I need to get y by itself. So to move this minus 1/2 to the other side, I have to add it. So x plus 1/2 equals y. These two functions are inverses of one another. This is what I started with. I switched x and y, solved for y. If you were to graph these two equations on a coordinate plane, they would be reflections of one another over that line y equals x. Super fun. Okay, so 3 steps. I would give you a point for every single step when it comes to the test and the quiz for this chapter. Okay, let's do a couple more. F of x. Change f of x to y. That is step 1. Now apply the definition of inverse. Switch the x and y around. That is step 2. Step 3, solve for y. So I want to get rid of a denominator. This is y divided by 3. So I need to multiply the 3 to the other side. That's the inverse, and you're done. Here's another one step. F of x becomes y. Step 2, definition of an inverse, switch x and y. So x equals y plus 2/3. Last step, your inverse is what you get if you solve for y. So x minus 2/3 equals y, because I have to take this plus 2/3, minus it over, so that way I'm isolating y. So these are examples of one-step functions where you can find the inverse. Well, obviously they're not all going to be one step, so we're going to go ahead and try a couple of them that are two-step right now. Step 1, f of x, change it to y. Now, I think the easiest thing to do here, because I do have that set of parentheses, I went ahead and I distribute. You could go ahead and divide it and do some other things, but I do think it is going to be easier just to get rid of the parentheses right off the bat. So I said y equals 3 times x is 3x minus 3 times 7 is 21. So step 1 is all of this. I changed f of x into y. I got it into a format where I'm ready to go. Step 2, switch x and y around. So x equals 3 times y minus 21. Now you have to isolate y. So whatever's on the same side as y but not touching, you want to move that first. So step 1, I would add 21 to the other side. So I have x plus 21, you'd still have 3y. Y is not alone yet. I need to divide by 3. It is totally fine for you to take this 3 and just put it underneath both terms. If you wanted, you could say x over 3 plus 21 over 3 is 7. This is another way to write it, but I am totally fine if you do it this way, because you could say, okay, add 21 divided by 3, done. These two solutions are equivalent. One answer is not better than the other, so I like this one because to me it's one less step. Trying to save you some time. Let's look at one more two-step, and then we'll go to our next idea for the day. Step 1, f of x becomes a y. Step 2, definition of an inverse, x and y switch spots. So x equals 5y minus 7. Last idea, I need y by itself. So I need to take the 7 and add it over, because right here it's a minus 7, so I have to do the inverse operation. I have to do the other. So instead of minusing, I have to add it. So what I have left is 5y. This is not your inverse yet. Your inverse occurs when you solve for y. So I need to divide everything by 5. And again, go ahead and just put that 5 underneath the whole numerator. Totally fine. Okay, so that was our second idea. So far we've looked at the inverse of relations, set of ordered pairs, tables, that sort of thing. Now we looked at how do you find an inverse of a function. Well, they're going to take us now and kind of combine it. So we're going to look at graphing, but in function form. So this is making sure that you remember how to graph something if it's in the form y equals mx plus b. Okay, so here is my function, f of x. That's the same thing as y equals negative 1/2 x minus 5. If you are graphing something in y equals mx plus b form, sorry, I'm getting my ruler here, okay? If you graph something in y equals mx plus b form, remember whatever's after the x, that's your starting spot. So here I go down 1, 2, 3, 4, 5. That is called your y-intercept. Now the number in front of x, that is your slope. Your slope is your rise over run. Remember, you always run to the right. If your slope is positive, you go up and to the right. If your slope is negative, you go down and to the right. This is negative, so I go down 1 to the right 2. From geometry, you should have learned that it only takes 2 points to make a line. So I could take those 2 points, there's my line. Okay, so we graphed it. Then write the inverse and graph. Well, here's what we just learned. In order to change this into what's called its inverse, I have to switch x and y. So x equals negative 1/2 y minus 5. So I changed f of x to y, there's step 1. Switched your x and y, there's your step 2. Now I need to get y by itself. So I'm going to add 5 over. So x plus 5 equals negative 1/2 y. Now typically you would divide. Well, this is a fraction. Remember in math you're not allowed to divide fractions. What you do is you actually multiply by the reciprocal. So I need to multiply both sides by negative 2 because that's the reciprocal of a negative 1/2. Because on this side, negative times a negative cancels. 1/2 of 2 is 1, so it's just 1y. Because there are 2 terms on this side, when I multiply by the reciprocal, when I multiply by that negative 2, I do have to make sure that I multiply it to both the x and the plus 5. It can't just go to one term. You have to distribute. So y equals negative 2x minus 10. Now here, I know this isn't going to fit very well, but I didn't want you to have to draw out all of the grids, so we will just go for it, okay? So minus 10, we'll just have to estimate. So this would be 6, 7, 8, 9, 10. Do the best you can. Your y-intercept, yes, it's going to be off the graph, okay? Now negative 2 over x, that's the same thing as negative 2 over 1. So I go down 2, go to the right 1. Again, it's just an approximation where that would be. That's all that it would take to go ahead and make your line. Okay, so again, we graphed, we went down 5, down 1 over 2, graphed. Changed f of x to y, switched x and y. We had to add the 5 over. You cannot divide by a fraction, so we multiplied by the reciprocal, which is negative 2 times x is negative 2x. Negative 2 times 5 is a negative 10. So I go down 10. My slope is negative 2, so down 2 over 1 connected, and you're done. Okay, let's go ahead and do one more like that, just to make sure. Okay, so again, this is in the format y equals mx plus b. Let's change all of these so you're actually going by ones. If you look, they said that these were 8s and negative 8s. Everything is going to fit better if we just go in increments by 1. So this is 1, 2, 3, 4. And this is positive 1, 2, 3, 4. Okay, if I go to graph it, my y-intercept is up 2. My slope is 2/3, so up 2, go to the right, 1, 2, 3, done. It only takes 2 points to make a line, so go ahead and graph your line. Done. Now we have to find the inverse. So I change f of x to y. Definition of inverse, switch x and y. So x equals 2/3 y plus 2. Now you need to solve for y. So step 1, I'm going to take that plus 2 and minus 2 to the other side. Now here again, you cannot divide by a fraction. I can't take 2/3 and divide it to the other side. What you do is you multiply both sides by the reciprocal, because 3 cancels 3 and 2 cancels 2. So now all I have left is a y. This 3/2 does have to go to both the x and the negative 2. So 3/2 times x is 3/2 x minus top times top, bottom times bottom. 3 times 2 is 6. 2 times 1 is 2. 6 over 2 is 3. So here's my inverse. So I go down 1, 2, 3 to start. Now your slope is 3 over 2. Remember, the top is your rise, the bottom is your run. So I go up 1, 2, 3, go to the right 1, 2, graph it. And again, if you were to look, that if I look at these two, my original function and my inverse, you will notice that they are reflections of one another over that imaginary line y equals x. Okay, so that was another idea, just kind of combining the first two of, look at this, you get a reflection. How do you graph in y equals mx plus b? So pulling back that skill from the beginning of this year as well as Algebra 1, applying our new inverse function. So kind of starting to mesh it all together. Now here's one thing. They do put this in our inverse section because inverses, you're switching different things around. It's a totally different way to look at things. But they're going to give us a couple story problems where what they want us to do is work backwards. And so instead of starting at the beginning of the problem, you actually start at the end. And in order to work backwards, it's kind of like Jeopardy. They give you the solution, you have to be able to tell them the question. We have to apply inverse operations. So remember, our inverse operations are those that undo one another. So the inverse of adding is subtracting, and the inverse of multiplying is dividing. Okay, so let's go ahead and do this. It's different. It's a different way to look at it. There's only a couple of them, but let's go ahead and try it and see what you think. So here's an example. Jacob buys a CD online for 20% off the list price. So right here, okay, they want us to start thinking, if you look at a CD online, right, and it's 20% off, what that means is that you have to pay 80% of the price, correct? If you buy a CD online, it's 20% off. What you have to pay is 80%. So if you wanted to find the new ticket price going forwards, you would take the original price times 0.80. That's the new price. Okay, so just walking you through this. He has to pay $2.50 for shipping. Now, typically, when you pay for shipping, you add on to your amount. Now, when we go backwards, we have to do inverses, okay? So rather than adding, we'll be subtracting. His total charge was $13.70. We want to know what was the price of the CD. So again, they want us to work backwards and use inverse functions, okay? So I'm starting at the end. The price was $13.70. If I go backwards in the problem, yep, there was the total. The next number was $2.50. We have to do the opposite of what you would have done. Typically, when you pay for shipping, you add to the amount. We're going backwards using inverses, so I have to minus that $2.50. So $13.70 minus $2.50, we have $11.20. Keep going backwards. Now here we got to the point where he got to have 20% off, meaning he had to multiply the original price by 0.80, because then he would be paying 80%. So rather than multiplying by 0.80, we are doing the inverse operation, so we need to divide by 0.80. So if I take 1120 and I divide by 0.80, I get 14. So this tells us that when Jacob found that CD online, the price was $14. He got to take 20% off, then he had to pay $2.50 for shipping. So let's go back and do this forwards, okay? Let's say that you knew this. So he had $14, right? We're just checking our work. He gets 20% off, so that means if he multiplies it by 0.80, that's the new price. His new price is $11.20. He has to pay $2.50 for shipping, so you add $2.50 to that. His total would be $13.70. That's what it was. So it's being able to take a problem apart where you know the answer and you know bits of information along the way, be able to go backwards to answer the final question. One more question, and that is it, guys. It says if you are making tea, you use 1/6 of a teaspoon of tea for every ounce of water, plus a teaspoon for the pot. Okay, so at the end, you're just gonna have to add that 1. Use the inverse to find the number of ounces of water needed if 7 teaspoons are used. So we are starting at the beginning. There are 7 teaspoons of tea being used, okay? So going backwards, 7, that's where we started. And it says plus a teaspoon for the pot. So we have to minus 1, so now we're at 6. Okay, now here, what you typically would do if you have 1/6 of a teaspoon per ounce, you'd have to take the number of ounces times 1/6. We're doing opposite operations, those inverse. So rather than multiplying by 1/6, we're going to divide by 1/6. So if I picture this, remember in math, you cannot divide fractions. So I keep the first value the same, change divide to multiply, flip the second fraction upside down, making it 6/6, which is 36. So it would be 36 ounces of water is how much you would have to have if you were going to use 7 teaspoons of tea. Okay, now guys, there is a change to this. This is still your assignment. Your assignment is 1 to 29, okay, because today is Thursday if you're with the schedule. Now tomorrow, the plan has been changed where it is a teacher work day. It's like a teacher in service. So we will not be having our Zoom meeting tomorrow where you can answer questions on 1 to 29. So as you're working through these, if you have a question, please message me. You can message me in Google, you can send me an email, you can message me on Remind, but don't be shy, okay? So again, tomorrow there is no Zoom meeting. Tomorrow is a day off for you. If you have questions on 1 to 29, please ask me. Also, in your original packet, tomorrow the plan was for you to do a 7.2 quick quiz. Go ahead, throw that out. You no longer have to do that. So when you finish your 1 to 29 today, you get to call it a week. No school on Friday. You get Saturday, Sunday off. And then I'm not sure if you looked, but you also get Monday off. So I will come back and kind of give you some new directions if you watch our Google Classroom. But I hope you had a great day today and have a great long weekend. You deserve it. Talk to you soon. Bye.